In this lesson, we're going to take a look at another resource that I introduced to the DevHabit RESTful API. I added the tags resource behind the scenes, and I'm going to walk you through all of the changes that I made and gradually introduce you to the new resource. You will see that this isn't too much different than what we have already implemented, which is why I don't want us to spend a considerable amount of time on this. So let's jump into the code and explore the new resource that we exposed on our REST API. If you go ahead and download the latest version of the source code that's going to be available from right under this video, you will see that there were some changes that were made behind the scenes. If you open up the entities folder, you will find a new entity called a tag, and this is going to allow us to categorize our habits based on the tags that we create ourselves. I have two main ideas when it comes to using this resource. First, I want to expose another resource on my API so that you have more examples of working with different entities. Secondly, I'm going to use the tag resource or the tag entity to introduce a many-to-many relationship between the habits and the tags. This is something that's not so complicated to implement inside of a SQL database, but it opens up some interesting options when it comes to exposing this functionality from a RESTful API. We're going to talk more about this in our next lesson, where we are going to discuss how to work with child resources, but for now, let's focus on our new resource, the simple tag. It contains an identifier, a name, a description, and some datetime properties so that we can track when it was created or updated. Inside of my database context, I introduced another database set for our new entity, and of course, there is a strongly typed EF core configuration called the tag configuration that configures the primary key, the maximum length of some of the properties, and there's also a unique index on the name property of our tag. Let's say that this is a business constraint inside of the DevHabit application where we aren't allowed to create a duplicate tag. Now, this is going to be even more interesting when we introduce the concept of a user, where we really want to associate the tags to the users and not necessarily have them globally unique. So just keep this in the back of your head as we evolve our application, but for now this should be sufficient for us to implement the required functionality. So let me close this down, and I will also close down the database folder. Now let's take a look at our new controller, the tags controller. I decorated it with the API controller attribute, and I added the base route of tags, which is the name of our resource in plural. And then you will notice that the implementation is very similar to what I already did with the habits, which is why I didn't want us to duplicate the work again. We have a get endpoint to return a collection of tags. I'm also wrapping this in a DTO so that my collection of tags isn't exposed as a top-level property. Then we have our second endpoint, which allows us to retrieve a tag based on the identifier, so just fetching a single resource. Our next endpoint is a bit more interesting. We are creating a tag by passing in a create tag DTO. Let's take a look at what it looks like, and you will see that it only contains a name property and an optional description. Now let me close this down, and if I go back to the endpoint, we're first going to convert the create tag DTO into an entity instance. For this, I define a respective mapping method that's also going to assign the unique identifier for the tag, and it will assign when this entity was created. Now back to the controller, before we can insert this tag into the database, we want to check if there is already such a tag with the specified name. Remember that we want the tag name to be globally unique, and this is how we can achieve it. Now in this case, if we do run into a situation that a tag with the provided name already exists, then I need to return some sort of error. Now you could return a 400 bad request, but an interesting status code to consider is 409 conflict. This can be used when you run into a conflict on the state of the resource that you are trying to modify. A typical example of this is violating unique constraints. This could be a unique constraint based on the URI if you want to support, for example, upserting on a put or a patch endpoint, and a resource with the same URI already exists. But you can also use this for unique values inside of your system. For example, attempting to register a user with a duplicate email may lead to a 409 conflict response. This is another example where if we create a tag that already exists in our system, we're going to return the 409 conflict status code. If we manage to get past this condition, then we're just going to insert this into the database, persist it, convert it back into a tag DTO, and return a 201 created response with the location header set, and we're also going to include the complete representation of the tag in the response. Now if you're paying attention, you might notice that there is a race condition here. Let's say that this check passes, and before we attempt to persist the changes in the database, a concurrent request already creates the tag with the given name in the database. In that case, we have the unique constraint inside of our database protecting us from inserting a duplicate tag. So the save changes is going to fail, and if we don't handle this exception, we're going to get back a 500 internal server error on the client. Now, if we consider how likely the race condition could happen, this might be an acceptable solution. So I'm going to leave the implementation like this, and I'm confident that we can't run into a situation where we end up creating duplicate tags. Let's also explore the other two endpoints that I have. There is the put endpoint for updating a tag with the specified identifier, and of course I have a dedicated DTO for updating my tag details. Now if I take a look at this DTO, you will see that I can only update the name of the tag and the description. So this is a very simple resource, and this is on purpose because all we are doing here is just data manipulation without any interesting behavior. Lastly, we have the delete endpoint, where we can delete a tag based on its identifier if it exists, and we can either return a 204 no content response or a 404 not found if the tag doesn't exist. In the DTOs folder, there is now a tags folder that contains my DTOs as well as the mappings, which you saw a moment ago. I have a toDTO method, a toEntity method, and an update from DTO method. And there is also the tag queries definition, which contains my projection from my entity instance into my data transfer object. Now this is a very simple query, and we are using this inside of the toGet endpoints to apply my projection. I also added our respective database migration for creating this table in our database, and this migration will be applied when we start the application. So let's go ahead and do that, and we are going to test out the functionality that we exposed using the tags controller. Inside of my Postman collection, I have a set of endpoints for working with the tags resource, and let's begin with the get endpoint for returning the collection of tags. If I send this request, we're going to get back a 200 OK response with our collection wrapper object, and you will see that we don't have any tags inside. So let's go into the post request, which is going to create a new resource. And for example, I want to create a new tag with the name of coding. The description is null, and if I go ahead and send this request, we're going to get back a 201 created response, the representation of our new resource, which now has a unique identifier assigned. If I take a look at the response headers, in the location header, I now have a fully qualified URL where I can retrieve my new resource. So if I go ahead and send a GET request to this URL, you will see that we are getting back a 200 OK response and the same resource representation. Let's close this down, and I will just use the identifier of my new tag for the remaining requests. If we go back to the request for returning all of the tags, now you can see that we are getting the one tag that we have inside of the response. If I try to fetch the tag with the new identifier that I have, you can see I'm getting back the same response. And if I specify an identifier which doesn't exist, I will get back a 404 not found response. Now, if I try to update this, let's say I want to change the description and I specify the correct tag identifier and send this request, we get back a 204 no content response. If we try to update a non-existent tag, we will get back a 404 not found. But we also have some validation present because we are using the API controller attribute. If I try to send a put request with the null value for the name property, then we're going to get back a 400 bad request response saying that the name field is required. Now, if I go ahead and send another request to get back the tag instance, you will see that the description has been updated, and so has the updated add property to specify when this tag was last modified. And finally, if I go ahead and send a delete request, we're going to get back a 204 no content response, which means our delete was successful. If I send the same request again, we will get back a 404 not found because this tag doesn't exist anymore. In the collections request, you will see that we are not getting back a response. And finally, I want to demonstrate the 409 conflict response. So let's send a request to create the tag with the name of coding, and we get back a 201 created response. And now if I try to send the same request again, we will get back a 409 conflict response. The response body doesn't contain a problem details response. This is something that we are going to tackle in an upcoming lesson, but it does say that the tag called coding already exists. Now this is what I was talking about when I was saying that you can implement your post endpoints to be idempotent. If you have a way to determine that you have received a duplicate request and you don't want to duplicate your resource, then you can make sure that duplicate post requests don't create additional resources on your server. And this is a good example of that. So this was a quick overview of another resource that I introduced into the DevHabit application. A novelty here is using the 409 conflict response for a post request to help us maintain our business rule that the tag names have to be unique. And now that we have our tags resource implemented in the API, we have a way to categorize our habits by tagging them. This is what we are going to implement in the next lesson, where I'm going to show you how we are going to be working with child resources and maintaining relationships between the resources in a RESTful API.